Okay, let's get started here on the last topic, programmability concepts. And that's where we're going with this thing. First, what is it? What are we doing? What are some of the conceptually, what can we do? And then programmability. And automation of network management is impossible without the ability to have code that performs a repetitive task. And that's one of the things we want to do. And I'll go back to the wireless LAN controller. I keep going back to. We can go make an SSID on 42 different autonomous access points, or we can make it once on the wireless LAN controller and send that information to the various resources that we have. We want to automate and program, and some software is going to do several tasks with these things. Analyzes the data in the form of variables, and we looked at just a few minutes ago how we might be able to get that information to provide values for the variables that we can use in the situation, in the systems themselves. And then we're going to make decisions based upon analysis. The analysis, what do we have? We've got to get all the information about the entire network, and it looks like we probably can do that with the APIs. And from that, have the programs, the applications develop or provide, calculate all of the information that we're going to need for these things. Take actions to change the configuration. We want to change the IP address of something. We want to name something. We want to shut down an interface. We want to bring an interface up. We want to add a network to the topology. Or what he was showing in the video for the DNA center, maybe we want to add an entire location to our network, a whole building, a whole bunch of networks, a whole bunch of devices. We want to be able to do that in an automated manner. One of the places that I know that uses programming or scripting or automation in order to update devices is Advance Auto. And Advance Auto's got, I don't know how many stores around the country, around the world. They were headquartered in Roanoke. Their data center was still there, so we had a lot of students who went to work for them. When they get ready to update something, like the workstations in the stores, they script it. They automate it. They don't go to 50,000 individual workstations, point of sales, and make a change to it. They send an automated update to those devices. What they have to be able to do or have to show before they can send the update is show that they can undo the update. What if it breaks stuff? And they had one a few years ago that did break stuff. They couldn't take credit cards for a number of hours. That really impacts your sales. That really impacts your business. So what can we do with these things? We can make changes. May take actions to change the configuration, different automation on different devices, and we need useful, well-defined conventions, protocols in order to be able to do those things. The web services, and we looked at an XML file, what an XML looks like in an XML template, but web services, the applications, data sources accessible through HTTP or HTTPS, provide interoperability, communication, data exchange between applications. The Postman API that we used an HTTPS connection in order to get that information. Web pages, XML is the way it's going to go. We had a template, we had a data file, and when we put those two together, we had an HTML file. We had a web page. Categorized by standards and protocols. XML RPC is the simplest one. There are going to be a number of those. Remote procedure call. Universal UDDI is an XML based standard used for describing, publishing, and discovering web services. A catalog of available web services. Service-oriented SOAP, XML-based protocol. Representational state transfer. We saw that term, the REST API. Architectural style for creating web services for those things. a RESTful API, and you get down here, do repetitious work done. Well, if only we could do it that simply, but that's really what we're doing with these things. We have a request here and a response. The RESTful APIs, representational state APIs, created according to the REST constraints, all of the well-organized that we talked about a little bit earlier in order to do that, and it uses the HTTPS requests to manipulate the data. So we're using HTTPS to get send information using the application programming interfaces. In this case, we're going to decouple the data from the underlying resources so that one RESTful API can meet the needs of many types of program calls and many other data formats. And we looked at XML and JSON. YAML is YAML ain't XML or something like that is what it stands for. Uses less bandwidth than the SOAP protocol, but what can we do? We use the HTTPS in this guy to get the information. I'm pretty sure that it's timed out now, but again, keep coming back to this because we can get a lot of information about these things. And let's do a send here, and I'll bet you, well, it's still valid. That's pretty unusual for this amount of time. Usually they would have timed out by now. But all of the information that we can get and now put into a source file or a program, a data program, some sort of manipulation of that data in order to get to where applications use the API to communicate. One program learns the variables, the data structure is used by another program. Kind of what we saw with the XML, although that was a manual update. And go back, and it's still trying to, say time and again and to emphasize that what we're doing in this automation is we're going to get the information, putting it into maybe into a data file, using some sort of a template in order to organize the data, and then using a program to manipulate the data that we have. You can make logical choices based on the values, just getting them and then putting them into a program to say, hey, let's just make a list of all the MAC addresses and the interfaces that are associated with them. Hey, now I've created a MAC address table. I've got the IP address, the name of that device. So now I have a MAC address table that I can send to the physical device. And it doesn't have to do any of the calculations. All it has to do is use its ASICs and send the data out the correct interface. We can create new variables, delete variables, allow the programs running on different hardware to work cooperatively. The APIs do. They're the standardization that we're going to use for these things. Lots of things use APIs. If you get Postman and register it, you'll get all sorts. I've gotten a couple of emails from them that we have this API, that API, to be able to see information, to get information, work back and forth. There used to be one that is no longer available. They've taken it down. It was called the SAPI, the Star Wars SWAPI, Star Wars API, which had all the information in the world about Star Wars. I guess whoever was maintaining it or paying for the web server site didn't really want to do it anymore. So it was kind of a neat one to look at. But there are other APIs, other programs that you can look at through Postman, other application programming interfaces to do those things. So lots of things are going to use APIs. Software developers are going to add APIs so that other applications can use the features of it, and the developers may write the codes, and then the software developers kits, the SDKs, have pre-configured code. You can find a lot of pre-configured code on the internet. Google is a good place to find those things. CCNA, what we're talking about, is going to use REST APIs, representational state transfer, are the ones that it's doing. So the REST APIs, the characteristics, constraints of them It's a client-server architecture, and then this constraint, and the description, this constraint separates the user interface from the data. It has statelessness. Follows the client-server, as the server does not retain client information after a request has been completed. All the information required for the client request is sent within the request. Cacheability requires responses to define themselves as cacheable or not cacheable. A layered system requires transparency for clients that are not directly connected to the end server. Uniform interface, provide uniform interface including the resource. And then code on demand can be an optional constraint that goes the RESTful representational state. The client-server architecture that we would use for this, the developer created an API to act as a server, the REST server over here, and other applications can make calls by executing the code, and then the web pages are usually used to make this. We're going to use the HTTP get and put those sort of things. The get, we're going to get information, and then we had the post where we sent information. This thing here, and somebody asked, did things change going from one direction to the other? Now they just basically took the one that they had here and just drew an arrow in the other direction to show that it's going back. So one, we have the API call, the URI, the HTTP, which we did in Postman, and then with the API we get the response that comes back to the REST client, to the RESTful client for these things to get the information. Variables, the applications are going to process the data. The same general action, the program needs data to process. The input process reads the files, queries the databases, makes the API calls, which we did get our information. We didn't do anything with it. We didn't put it into a database or anything like that, or a document when we got it, but we did get the information. And after the data, the program needs, the program processes the data, make comparisons, makes decisions, create new variables, perform math operations. And that's what the scripting is all about, to make the comparisons, to make the decisions, if this, then that. What are we going to do with these things? And all logic is going to use variables. And the variable name or the label is then going to have an assigned value. This is a very simple Python program. The reason that they like Python is because they say easy to learn. Nothing's easy for me at this point. At this stage lately, it's hard, but it is relatively simple because we don't have to do a whole lot of pre-definition for these things. In the sample program here, we have the three quotes here. It says sample program to multiply two numbers, x equals 3, y equals -4, and then we just throw the z in here. Heading equal, quote, the product is, and then the actual, what are we going to do? We're going to print the heading and then x times y. When we do that, we'll get heading is -12 when we would do those things. So this is a really simple Python. You have to install Python, obviously have Python running in order for those things to happen. The variables, the simple variable has a single value. They can be unsigned integers, signed integers, floating point numbers, or text. And if you go back to here, we had all of those. We had an unsigned integer, a signed integer, a floating point number, and text. That goes on with these things. The program's more complex structure for these things, and then the data structure defines a related set of variables, and Python uses a list of variables. One variable name is assigned and then a value that is in the list, and network automation might find the list handy, the list of devices, list of interfaces, list of different things that we're going to do, and kind of what I tried to talk about a little earlier, and it's going to be a key and then value pairs. Python is going to be. with this thing. So the list, we're going to get a list of elements, a list of the interfaces. And then down here, the variable list 1 is a list of Python is called an array list gig 00, 01, 02 for this thing. Then we can get the information about the interfaces in the dictionary here, an associative array. So the config speed is auto, the config duplex is auto, the config IP here is 10.1.1.1 with these things. We can get a list. We can also, now that we have a list of interfaces, we can send information. HTTP verbs that are going to be used are post, get, put, delete. So post is what we did to get the information back. It is to create a resource, and the resource that it created, it gave me my key, my authentication key to get there. The code that we got with the post one that we get. The next one we used was a get to read the resource. We didn't use a put or delete because it's a read-only one. A put, it was going to update or create a resource, and then delete to remove a resource. The verbs correspond to the CRUD operations. Going to have a little table here next, but the create allows the client to create some new instance of variables. The read allows the client to retrieve the current value, update to change it, and then to delete allows us to delete something from the server. So we have these different variables: create a new structure, read, update, delete, CRUD, and what the verbs that they represent: create, post, read, get, update, patch, and put, and delete is used for delete when we look at those things. The URI, what we're going to do, REST uses the URI to specify the resource. HTTP acts on that. And then each resource has a related set of variables used to create the API set of resources to make it available. Here we use the get for the URI 3, which is down here. We get a resource set. The format that it's in, the protocol, the destination, and then the path that we get here. And this is the path that we actually use to get that the network device, the list of devices that we had in the Postman. Data encoding, and this is just kind of a okay, here is what it is. Data encoding, converting the data from one form to the other. URL encoding is going to ensure that the URLs conform to the ASCII character set for these things. So one to the other, converting data from one to the other. A PDF, you can open it in Word and convert it from a PDF format to a Word format. So physical reports stored on server 1. And then when we get there, the browser, we're going to be able to open it in a browser, maybe not be able to open it in a browser, depending on whether the application layer supports it. The presentation layer is responsible for being sure that that happens. And I think we talked about this. You may get into a situation that you go and try to look at a doc file, and it'll download it. You go to a PDF and it'll open it in the browser. The browser supports that particular format and can open it. It didn't support the doc format, but it did the PDF format. Software configuration management options here. It's going to enable the developers and the IT personnel to organize the software, the code, the documentation. What do we want to do here? Configure, identify, baseline, control, change the management. Lots of different options. And prevent configuration drift. Let's look at configuration drift, then we'll take a break and we'll have just a little bit to finish up after lunch. Somebody made a change, but the configuration drifted away from the standard. We have a standard configuration, and when we start out, everything is the same. If you've got you and maybe one other person, if you've got a you can maintain that standardization. But if you've got 10 or 15 different people, it's difficult to do that. Somebody makes a change and everybody doesn't do the same thing the same way. So we may have a little bit of a different variability in the configurations. In conventional CCNA, we're still going to configure one at a time, and then how are we going to ensure the consistency of these things? Because when you make a change, then you make the save, there is no indication about what you actually changed on it. What was it before? What did we change it from to? No means to provide a check of the configs. Did we do it right? Did we put the correct one in for these things? Everybody's not going to need the concept that we're going to look at here as we go through this thing. But if we have one engineer, one you, one me, we may be okay because we know what the configurations are, and we hope that we're not going to make any typos while we're doing those configurations. We may need to do 2 or 3 devices, but that's really not an exorbitant number to do. Maybe even up there 8 or 9 or 10 devices to do a manual configuration. At some point, you're going to say, we really need to do some automation here. Configurations don't really change that often. Much as we go through in the labs to say, yeah, you gotta. How often do you actually change things? How often do you actually change the infrastructure in a network? We talk about dynamic versus static routing within the enterprise. These things, and not really a whole lot. The infrastructure itself. Although, you may add a room, you may add a network, you may add a floor, you may have to add a number of devices, and then if you had the statics, you've got to go in and change that on all of your devices, whereas the dynamics would pick it up. But in this case, the configurations, if we have just us, we can maintain a standardization because we know what we did to the devices themselves. In a large enterprise, that's not necessarily going to be the case. And we're going to have historical data in change management is going to work poorly if the device has had multiple configuration changes. So in this one, we have an enterprise network with multiple engineers, and we start out with all of the devices having the standard configuration. And we have Bob and Alice are on call. This is a really big enterprise, and Bob gets a call at 1 o'clock, and he resolves the problem. He makes a little configuration change and saves it, and the change gets implemented. At 4, Alice gets a call about a different issue, resolves the configuration change. The next day, they forget to talk about these things. They document the changes because that's what they're supposed to do. We document the changes that goes on, but now the one doesn't know about the other one. We have in here the BR22 and the BR33 have a unique configuration where the other branch devices, other branches, or the other devices are consistent with the configuration that we have. This is going to be called configuration drift, and it becomes a bigger problem as the enterprise gets bigger and as we go over in time, because we have no tracking of the change history with this thing. What changed on each line? We don't know. I mean, what Bob said that he made a change, what did he change? Alice said that she made a change. What did she change when they did this? And then what old configuration was removed? What came out? What went in? Don't really have a good record of that. External systems, we may be able to record the data, sit outside the configuration and require the analysis. And we're going to rely on humans to follow up on the operational process. And in our case, the humans did part of the follow-up, but they didn't do a complete. So what we're going to have here in the centralized configuration file and version control, we have Alice and Bob are going to make these changes on this thing. The config file does not show what was changed. Larger networks, hundreds, maybe thousands of devices we're going to need to be able to manage these things. First step is going to be a central storage of the configuration files. And then which file is truth? What we're going to do then after they make their changes is we're going to be able to compare this to the to the standard, to the truth, to the gold standard. And you guys that have done virtualization, you have a gold standard that you use as the basis. If the central file and multiple tools to manage the configurations, the version control is going to track the changes, who, what, when, where, and how, all of the things that we talk about with these things. But in centralized management, better control the configurations. We have the ideal here, and we're going to edit the ideal. The new challenges with automated configuration management tool. The changes should be made on the centralized file, and then they're going to be pushed to the device instead of on the individual devices. And after they're updated, after the update's completed, both copies should now be identical. So we have the ideal is going to be centrally located. We edit it, it then gets pushed to the device. And on the other devices here, centralized management, and this one we have the ideal, the running copy, and then we compare the two, and we can compare the two and see what the differences are, what changes might have been made with these things. Remedy the configuration inconsistency, but it may not. Eventually somebody's going to log into the device and make a change locally, and that's always going to happen. And that's where the comparison comes in. The configuration tool can monitor the configurations and determine whether they differ from the standard. Do a comparison of one to the other for these things. Provisioning, yeah, I know we kind of jump around. Provisioning is one of the aspects that we could do. It's the core functionality to implement changes, the ability to choose which devices to configure, determine if the change was accepted, revert to the original configuration if it didn't work. Kind of the things that I talked about a little earlier about what I know for a fact that Advance Auto does on their tens of thousands, maybe even hundreds of thousands of point of sale devices, computers that go around. They have to come into consistency. They bought Western Auto a few years ago, and it took them a tremendous amount of time to bring the Western Auto data IT bring it into the fold because of the technologies that were used that were old, very old. So we have those abilities to do that. The ability to validate the change before implementing, try it out. And then to check the configuration after the process is completed. Did it work? Did the changes actually get made? Use the logic as to whether to save the running config file. Remember that once we make changes to the running config file, we really hadn't made permanent the changes until we save it to NVRAM, copy, run, start, or use the write. So the ability to check this thing, the ability to use the logic as whether to save it or not, the ability to present the config files as templates, and the ability to store the logic as a file. Let's look at the templates here for a minute, and then we'll do the tools after we get back from lunch. But we looked at a template a little earlier. May have similar devices, similar roles down here. We got the variables that go on with these things. The devices may have the same role. And the configs may be similar with these things. You know, when we go in and do a router OSPF, and then the networks that we're going to advertise, we can get that, and put that into a template probably, and then what's going to be the area number that we're going to use. If EIGRP, what's going to be the autonomous system number we're going to use? A lot of that stuff's going to be the same. So we can now take the information that you can see down here, take the information, and IP address, IP OSPF 1, the process ID can be the same on all of the different devices, area 11, and then router ID, we can add those, or we can do those, we can create data files to read that, and now we can take the information that we have, the information that we want to add, put it into a template, and push it to devices here. Some have the same, an excerpt from a branch router. The highlighted fields may be the same in multiple routers, and then we have configuration management tools that can separate the components into the devices themselves. So might one of these things look like a template here? Host name, and the host name is going to come from the data file like we looked at in the XML file. The interface gig00, the IP address, the subnet mask, the IPO-SPF, the process ID, the area numbers that we're going to use. So we can use these processes and processing in order to be able to automate the configuration. We can get information. We've seen that we can get information. You've seen a template, and we can take the information that we get, put it into it, manipulate it however we need, take it back out into a template, and upload it to the devices that we. So the next topic here are the tools that are in the objective, and the tools can define the logic and the processes and what changes to make to what devices and when to make those. So we have host, templates, variables, the things that we've talked about in order to be able to make the changes to the difference. And we may also have a data document, a settings document that we have with these things. The Puppet, Chef, and Ansible are the three programs that we have. And I think that if you want to play with one, Ansible is one that you can get an Ansible lab if you want to do this. And I think that the Lamley book actually has a how to set up an Ansible lab if you want to do that. But Puppet, Chef, and Ansible, the different tools that are available here. A Puppet, open source software configuration management tool to deploy, configure, manage servers used in cloud deployments, master-slave architecture, universal specifications to provide automation and administrative tasks. Chef, automation tool on Ruby, configuring and managing the infrastructure as code, provides recipes, as you might expect from a chef, to record, update information about the infrastructure. And Ansible is an open source automation platform commonly used for websites and documentation, uses a push-based architecture, sends the configuration information to the nodes in Ansible modules, and runs over SSH. Modules can be stored anywhere. No servers or databases are needed. For each, a slide, a little bit of a slide for each of these things that we have. Ansible installed on Mac or Linux. And when you get to do, and I've probably said this before, when you start doing some of this management and the different things, you need to know a little bit about Linux. So you might as well get a Linux virtual machine, play with it a little bit, figure out how to do some basic things with it. Ansible has playbooks. Files provide the direct actions, logic about what it can do, an inventory, provide the device host names with the information about them, which you might expect as an inventory. The templates uses the Jinja 2 language, represents the device configurations, but with the variables. Variables using YAML, a file can list the variables that Ansible will substitute into the templates. It's agentless, no agents required on the device, which I think could be an advantage. The other devices are going to need an agent on the devices, and not all devices are going to support these things. So what we have with this, kind of the same concept, the push model that we had earlier. We have the inventory, the templates, the variables, run the playbooks. We have the playbook, and then push the configuration information out to the device. The others are going to be in a push-pull arrangement. Puppet, again, installed on a Linux host. The manifest is a human-readable text file on the Puppet master using a language defined by Puppet, used to define the desired configuration state of a device. Resource class module terms refer to the components of the manifest. Template, again, uses a Puppet domain-specific language. These files allow Puppet to generate manifests. Is agent-based, which means we have to have something on the device, and not every Cisco device supports. It is I said a push-pull, it is a pull. So we're going to have the templates, the variables, and if we go back to the push, we had the inventory, the templates, and the variables. In this one, the pull model with Puppet, we've got the builder files, we've got the templates, the variables, and then the pull details and the pull config. The agent, one builder file, start the agent, pull the details, pull the configuration files from the manifest. Put this one in here. Chef is not exactly free if you look at it. The Essentials, $16,500 a year, up to the Enterprise, $150,000 a year. What do you get? You can see that in the little web page clip here for what goes. And it says it runs on a host. It doesn't specify what host it runs on, but it runs on a host. When we look at it, the resource, the configuration objects managed by Chef, a set of configuration commands for a network device analogous to the ingredients in a recipe in a cookbook. The recipe is going to be the Chef logic applied to the resources to determine when, how, and whether to act against the resources. The cookbooks are going to be a set of recipes about the same kinds of work group gathered for easier management sharing. And the run list, an ordered list of recipes that should be run against a given device. The summary slide for this one, the term for the file and what they are. The term for the file, Ansible is a playbook, Puppet's a manifest, Chef is a recipe. The protocol, SSH, netconf, HTTP for REST for both Puppet and Chef. The agent or agentless for Ansible, Puppet and Chef are going to be agents. The push or pull model, push for Ansible, pull for Puppet and Chef. And the difference with push-pull, a pull says, send me the information. Actually, what it usually says is, hey, send the information to me. Pull, a push just automatically sends the information. The next few slides here are going to hopefully cover the JSON and the JSON format. And I think that's what we were supposed to know. What does a JSON entry, I guess, look like? Interpret JSON encoded data. JavaScript and JSON are two of the things we use. JSON is a JavaScript object notation, so they're going to be related. And if you've ever tried to write a JavaScript script, I tried it once, it's got thousands, I thought, of entries that have to go into it. But JavaScript, a lightweight scripting language used for dynamic content and interoperability on web pages. The one that we looked at a little earlier today uses JavaScript in order to create those tabs. We had the data, we had the template, and then we looked at the web page. It had a whole bunch of entries, and we had tabs that we could use in order to see the different years. JavaScript is what is going to help us get those tabs. It's going to work with HTML and CSS. CSS is the configuration file that's used on a web page. And it's used a lot on websites today. So Java is there. It's one of the things that we need to keep up to date on our machines. JSON is an open text or an open standard text-based human readable text, and we looked at the differences on Postman between an HTML and it was HTML, JSON, and XML. What's more readable, and JSON is going to be the more human readable. Machines don't really care. So it's machine readable as well as human readable. It's a low-head alternative to XML used for the exchange of data in web services. Contains name, value pairs, and lists of values. And that's what's going to be the big deal, the thing that you need to take away, I think, from this. And we're going to have some examples of that. It's based on the JavaScript syntax, can be used with a lot of different programming languages. JSON, JavaScript object notation, syntax for storing, exchanging data, text written with JavaScript object notation used to represent variables, and then it's going to be human and machine readable. Same process that we had before, the API call and then on the REST server and then the API answer for these things. One to the other to get the information that we need from the machines. The JSON rules, a series of key value pairs. We're going to have a key and then we're going to have a value that goes with that key. The key is always in double quotes and the value format depends on the type. Commas separate if we have multiple entries, but it's always object colon value when we do this. Object begins and ends with curly brackets. Values can be strings, numbers, arrays, or objects, and arrays are just a list of values. Objects, a list of key value pairs within the curly brackets. Hopefully, I think I got an example of each of these that we go here. This is a sample list array. The square bracket, quotes, Dallas, Houston, San Antonio. Values only in this. The array is values only, and it's going to be, and the entries are going to be separated by commas. So we have the square bracket, the quotes, the comma separating each of the entries in the array. A JSON object starts and ends with the curly brackets. We have curly brackets here and did this thing here so we have an object within an object. We can do that. We have key value pairs, at least one, and we have the key first name colon last name, or first name colon value, last name in quotes colon the value, and all these are text strings. Text strings are going to be in quotes. The address colon the object, and then the object is going to have the entries within an object that we go the same process here: street number, street name, city, state, zip, and then we end the objects, open the objects, and then end the objects with curly brackets, curly braces, and then another object, another value pair. In this one, object with two key value pairs: the JSON object, the curly brackets, the JSON array here, favorite players colon, and then we have a list in quotes separated by columns in a square bracket, and then the JSON, another JSON array here, JSON array, favorite players, favorite teams. JSON object, a key value pairs: player, Messi, team, Barcelona, league, La Liga. JSON object, two keys with a value pair. So a key value for is the process that these things use. The curly brackets that define the beginning and the end of a JSON object. One of the kind of summaries, a couple of summary slides. The keys are in double quotes. String is in double quotes. A number is no double quotes. We can have lists, objects. The goal is to be human readable, and it is space tolerant when we look at these things. This you can, if you want to write some JSON, this will compare yours to the standard to see if you've actually gotten it down. And here, the same thing we saw earlier: HTTPS, the host name, address, the path to the resources, and then the query parameters that would go on with these things. One more JSON syntax slide here: opening, closing brackets. We have the double colons, the separators, the double quotes when we have these things that we go down the line. None of these actually have numbers in them. They all have character strings. The object value pair. Open the JSON files. We can import it into a web browser. We can open it in Notepad. Import a JSON file into Excel or other programs such as Python, and then you can have a JSON viewer that we would have for it. And that brings us to the end of the presentations. This thing here, and let me show you what it is, or try to show you what it is, if it'll open for me. This is a little coding lab. DevNet, the developer.cisco.com. Cisco gives away a lot of stuff that I'm still learning where a lot of it is. Finally open here on DevNet. Coding and Basics APIs. There are some other little courses here. Building apps with the Cisco DNA Center, DC networking, explore application-centric infrastructure, WebEx, Meraki, things that you may be interested in. But if you want a tutorial in coding, intro to coding, what is REST, getting started with REST APIs, hands-on exercise, brief introduction to Git, and then an introduction to Python. And then if you really want to keep going another hour, if you do all of this, they estimate 4 hours. I'm not sure it'll really take you 4 hours to do that. That is something that might be useful. Many of these might be useful to you, as at least for background, to be able to do these different things that we need to do. But before